Hi, my name is Catherine Hayhoe, and this is Talking Climate Change in Texas. When we think about climate change, often the first question that comes to mind is, do people agree with the science? This map shows public opinion across the United States by county. Anything that is blue is less than 50% of people agree with the statement. Anything that is orange is more than 50%, and the darker the color, the larger or smaller the number. So this shows the estimated percentage of adults who think global warming is mostly caused by human activities. If we zoom in on Texas, we can see that actually most of Texas is orange with the exception of a few of our northern districts. Whenever we talk about climate change, we hear people throwing out sciencey sounding arguments too, like it's just a natural cycle, or we haven't studied this long enough to be sure. You scientists are making the whole thing up. Sea levels aren't rising, they're actually falling. It's such a tiny amount of carbon dioxide, what are you talking about? It's such a tiny amount of white powder I just put in your glass, why won't you drink it? And of course, between the months of November and April, it's cold outside. We hear people say, it's been warmer before. Wasn't there a medieval warm period? Well, there was a medieval warm period if you lived in Northern Europe. If you lived in Siberia, it would have been a medieval cold period. And when we compare what it looked like back then to what it looks like today, you can see there's no comparison. What we're seeing today really is unprecedented in the history of human civilization on this planet. We've looked at all the natural factors that cause climate to change. It can't be the sun because we'd be getting colder right now, not warmer. The sun's energy's been going down the last few decades. It can't be natural cycles like El Nino because the entire planet is warming. Natural cycles just move heat back and forth from east to west, north to south, ocean to atmosphere, and back again. And it can't be orbital cycles that cause the ice ages because according to orbital cycles, the next thing on our calendar is the next ice age. Warming after the last ice age already peaked thousands of years ago, and we were slowly, gradually cooling until the Industrial Revolution. If you want to know more about all the natural causes of climate change in the past and how we know they all have a perfect alibi today, I recommend This Is Just a Natural Cycle, Right? Which is one of our global weirding episodes that you can find on YouTube. But the reality is that we have known about the science for a very long time. We've known that our planet has an amazing natural blanket of heat-trapping gases that keep us almost 60 degrees Fahrenheit warmer than we should be since the work of Joseph Fourier in the 1820s. We've known that digging up and burning coal, and then eventually gas and oil too, produces heat-trapping gases since the work of Tyndall in the 1850s. And Eunice Foote, in the 1850s as well, was the first to suggest that if carbon dioxide levels were higher at any time in our atmosphere, the planet would be significantly warmer. By the 1890s, we knew enough for a Swedish chemist called Arrhenius to calculate by hand the very first climate model. How much would the world warm if we doubled or tripled levels of carbon dioxide in the atmosphere due to digging up and burning fossil fuels? And then, by the 1930s, we had enough data to actually track global temperature around the planet and show that yes, indeed, the planet is warming as a direct result of our energy choices. That work was done by a British engineer called Guy Callendar, who published it in 1938. The reality is that the science underlying our understanding of our climate system and how humans are influencing it is so basic and so fundamental that if we're going to say that science isn't right, we also have to throw away our refrigerators, our stoves, and our airplanes. Because the very same science that explains how refrigerators cool, stoves heat, and airplanes fly is the science that explains how climate models work too. If you want more information on all the most frequently asked questions about, well, how do we know climate change is real? How do we know it's not the sun? How do we know that animals and plants won't be okay? I recommend skepticalscience.com. They have great answers to all of these questions, and they link directly to the original scientific studies so you can go as deep as you want. But Given all this information we have, given the fact that we've looked at all the other factors, given the fact that climate science dates back to the 1800s, we often think, well, when we see all those blue areas across the country, if they just knew the facts, surely they would change their minds, right? We just need more information, more education, more facts and data about the science. Well, this is why I really appreciate the social sciences. Social sciences don't study the planet, they study us. And when we look at us and how we interact with information, we see a very different picture. This is a study by Dan Kahan, who's a professor at Yale University. It was done about 5 or 6 years ago, and he tackled this question directly. He said public apathy over climate change is often attributed to a deficit in comprehension. People don't know enough science to avoid being misled. So if that's the case, what's the solution? Obviously, we need better education, more science. We conducted a study to test this, and we found no support. In fact, people with the highest degree of scientific literacy were not most concerned, they were the most polarized. And in his work, he went on to find that the smarter we are, the better we are at finding reasons and pieces of evidence, cherry-picking the data to support our pre-existing opinions. What's the real problem when it comes to climate change? The real problem is not that we don't know enough science. The problem is not that we need more information about the science per se, although more information always helps. The root problem is this. Our threat-o-meter, so to speak, is out of whack. Specifically, we believe that the climate solutions that people are proposing pose an imminent threat to our well-being. In other words, if we implemented these solutions, we would be worse off, not better. And on the other hand, we believe that the climate impacts really don't matter. They don't affect us at all. So why would we act to fix a problem that doesn't matter to us if the solutions we believe are actually more painful than the symptoms? As Galen Carey said, who works for the National Association of Evangelicals, many evangelicals, and I would just add people there, we oppose climate action not on a religious basis or an ideological basis or a scientific basis, but politically because we believe the government wants to take away our freedom. So when we hear science-y sounding objections to climate change, like it's cold outside, or it's just a tiny amount of CO2, or those scientists are making it up, or isn't it just a natural cycle? Those objections are typically smoke screens. They are smoke screens for the real problem we have. And the real problem has very little to do with the science and everything to do with the impacts and the solutions. So when we talk about climate change, now we're starting to figure out what's the most important thing to talk about why it matters to us and the places where we live, and what are solutions that are not negative, that are not punitive, that would not leave us worse off than we are today, but rather better. One of the most dangerous myths we've bought into is the myth that climate change is a distant issue. It only matters to future generations and to people who live far away. The reality, of course, is exactly the opposite. Many climate solutions are beneficial for us. They actually help us. And many of the climate impacts are very negative. They will have harmful impacts on our economy, on our health, on our agriculture, our water, and much more. Here's the data that shows not do you agree with the science that climate is changing and humans are responsible, but simply do you agree that the planet is warming? It turns out just about all of us do. The whole country is orange to dark orange. Do you think global warming will harm plants and animals? Just about everybody says yes, we do. Do you think it will harm future generations? Absolutely. This might look like the same map, but it isn't. It's a different map. So we agree climate is changing. It will harm plants, animals, future generations. Will it harm people in developing countries? It's still mostly orange, a lot more orange than do you agree with the science. But then we say, do you think it will affect people here in the United States? And we start to see a little more blue in the map. But then we ask the most important question, do you think it will affect you? And here's the answer we get. Hardly anybody thinks it's going to affect us. So now it starts to make sense, right? Our threadometer really is out of whack. We think this thing doesn't matter to us. And if it doesn't matter to us, why would we want to fix it? As some would say, if it ain't broke, don't fix it. Why do we feel this way? It's because when we talk about a changing climate, the number one symbol or image that people use, often on a cover of a book or poster of a documentary, is an animal that very few of us have ever seen in real life in the wild. And if we do see pictures of people who are being affected by climate change, those pictures are typically of people who live very far away from us on low-lying islands in the South Pacific with names like Kiribati and Tuvalu that we can't even really pronounce properly. So why does climate change matter to us if we aren't a polar bear and if we don't live on a South Sea island? Here in Texas, we already get a lot of crazy weather extremes. Anywhere else that you live, you have normal climate where, it's wet and it's dry and it's hot and it's cold. If we live in Texas, we know our climate looks more like this. We know that here in Texas, we have some really extreme conditions. We get floods, we get hurricanes, we have droughts, we have wildfire. In August 2018, almost 80% of the entire state was in drought. And by October, Central Texas was experiencing the wettest fall on record. Our conditions change here so fast they practically give you whiplash. So many people may say, well then why does climate change matter? We already have plenty of extremes right here in Texas today. And it's true, if you look at the number of climate and weather disasters, so droughts, floods, hurricanes, heat waves, wildfires, and more, if you look at the number of disasters that have caused at least $1 billion worth of damage since 1980, Texas is number one. The state of Texas has experienced over $105 billion weather and climate disasters since 1980, more than any other state in the country. So why does a changing climate matter? Well, first of all, we have to talk about the difference between weather and climate. Weather is like a single tree. It's what happens in a certain day at a certain time. So it can be cold, it can be hot, it can be wet, it can be dry. Climate, however, is like a forest. Climate is the long-term average of weather over at least 20 to 30 years. So this is the weather, hot and dry, cold and wet. This is the climate, the long-term average of weather over at least 20 to 30 years. Why does climate matter? It's because our entire society is actually based on climate. What do you mean, you say? I just remember weather. I remember crazy heat waves or ice storms or drought. Yes, but we use climate every day. We use climate to design our building codes, to figure out what type of crops we can grow where and when, to determine if we're in a flood zone or not, even to plan for future water. The long-term average climate of a region has everything to do with our agriculture, our water, our energy, our infrastructure, our economy, and more. That's why climate matters. So climate is kind of like driving down the road. This is one of our roads in West Texas, which are very straight because it's so flat. You can get a fair ways up Highway I-27, staying not only on the road, but even in your own lane, looking in the rearview mirror. Why? Because the road is so straight that where we were 5 seconds ago, 30 seconds ago, heck, 5 minutes ago in some places, is a perfect predictor of where we'll be in the future because the road is straight. But just before you get to the top of this map, there is a giant curve in the road with a row of concrete grain silos on the curve. What happens if you're driving up the road, looking behind you in the past, in the rearview mirror, and you hit the curve? Let's just say you'll end up somewhere where you did not plan to be. In that way, planning for the future based on the past is like driving down the road looking in the rearview mirror. It works great when the road is straight and climate is stable. But when there is a curve in the road, we can't only look backwards, we have to look forwards as well to make sure we stay on the road. So that's why climate matters. We know that we get heat and cold, wet and dry conditions all the time in Texas. That's just part of our natural weather patterns. But we have built our entire society on the assumption that the road is straight, that by looking backwards at past conditions, they will give us a perfect predictor of the average conditions in the future. Today, however, that assumption is no longer valid. Today, climate is changing. Now, we still get hot and cold, we still get wet and dry. That's weather. But our long-term averages and our statistics and our probability of weather is changing. We care about a changing climate because it alters our future average conditions that affect all aspects of our agriculture, our ecosystems, our resources, and more. But that's not all. As climate is changing, it is also changing our variability. So even though we still have extreme weather in both directions, our variability is getting stretched. And so the second reason we care about a changing climate if we live in Texas is because it takes so many of the risks we are already vulnerable to today and it exacerbates them or makes them worse. So we know that we are already vulnerable to more expensive weather and climate disasters than any other state in the country. It's because of our geographic position. We're next to the Gulf of Mexico, so we get hurricanes. We have dry interior areas, so we get droughts. We're far enough north and close enough to the mountains that we get really cold weather in the winter. We get pretty much every type of weather and climate disaster you can imagine naturally. So wherever we live, we are already at risk from naturally occurring weather and climate disasters, but today, those risks are increasing, and they're increasing for three reasons. So disaster risk is a function of three things. I teach an entire class based off this diagram, and you'll see why in a minute. There's a lot to unpack here, but don't worry, it won't take a whole semester. We can do it in just 10 more minutes. Disaster is a function of three things: exposure, vulnerability, and of course, the weather and the climate event. So think about exposure. If Hurricane Harvey had never come ashore, would it have been a disaster? Probably not. If you're really prepared for something to happen versus unprepared, something might not be a disaster. That's your vulnerability. And then, of course, you actually have to have the physical climate or weather event itself. Disaster risk is increasing right here in Texas and across the U.S., not just for one reason, not even for two reasons, but for three reasons. First of all, let's look at exposure. Exposure is increasing for the simple reason that our population is increasing globally around the world, as well as in Texas. Our urban population, some of our cities, are the fastest growing in the United States, and that means that we're also building more infrastructure. We already have trillions of dollars of infrastructure, almost $40 trillion in the US already. And the more infrastructure we build, the more exposure we have of valuable assets to climate and weather disasters when they come along. I mean, imagine if a hurricane hits an uninhabited and unpopulated part of a coastline. Not really a disaster, is it? But then it hits a major city, like Houston, and it absolutely is a disaster, a devastating one. It isn't just our exposure that's increasing. Unfortunately, today, it is also our vulnerability. How? Because if you look around at our infrastructure, if you look at our roads and our bridges, our rail and more, last year the American Society of Civil Engineers graded the infrastructure across the US and gave it a failing grade. They estimated it would take $4.5 trillion, which is about 15% of the infrastructure value we have, to bring it up to standards. They specifically gave almost everything a failing grade. Rail was the only thing that got a B, and then bridges and ports got a C+. That's not very good. That means that our vulnerability is increasing because our infrastructure is increasingly unprepared. And then, of course, in addition to the exposure and the vulnerability, we have number three, the weather and climate events. How are they changing as climate changes? Well, on average, we know that we always have a chance of rolling a double six. That's that crazy heat wave or drought or strong hurricane or flood. But what climate change is doing decade by decade by decade is sneaking in and replacing a number on those dice with another six. and then another 6. And all of a sudden, our chances of rolling a double 6 are going up. That's how climate change is affecting our extremes. What type of extremes? Well, we're seeing that our heavy rainfall risk is increasing. Why? Because warmer air holds more water vapor. So when a storm comes along today, there's a lot more water vapor up in the air for that storm to sweep up and dump on us than there was 50 or 100 years ago. When we look around the entire United States, we've seen since the 1950s that there's already been a significant increase in heavy rainfall events. In our region, 40% increase since the 1950s, especially across the eastern part of our region. What other types of extremes? Well, we also see that heat waves have become more frequent and cold waves have become less frequent. We still have them, of course, but on average, we're seeing more extreme heat than extreme cold. For example, from 1960 to 1990, we averaged, between 10 to maybe maximum of 20 or 25 days over 100 degrees across Texas. But then we had the summer of 2011. Some places in Texas experienced over 50 or even over 70 days over 100 degrees. When I saw this map, though, I couldn't believe my eyes because 2 years before this, in 2009, for the second National Climate Assessment, I had made a map showing what the average summer would look like by mid-century, which now is 30 years from now, in terms of the number of days over 100 degrees if we continue to depend on fossil fuels as our primary source of energy. And that map looked almost the same. You can see it says plus 40 years here. Of course, that was back in 2009. Now it's more like plus 30 years. Why do we care about a changing climate? Because it's loading the weather dice against us, making events that we have experienced in the past, for sure, because they're natural, making those types of events more frequent or more severe, or sometimes both. What other way is climate change weighting the dice against us? Well, we know that our droughts are getting stronger because, again, when it's warmer, water evaporates out of our reservoirs and our soil faster. And if there's no storm coming along to sweep up that water vapor and dump it on us, it just gets hotter and drier. We also know that forest fires across the western U.S. are getting larger, burning more area. We don't see a change in the number of fires because most of them are actually due to human ignition, unfortunately. But we do see that when a fire starts, it's burning greater area now because there's a greater risk of having hot and dry conditions when that fire begins. Last December in 2017, the Thomas Fire broke the record for being the largest wildfire in California, but that record was broken that same summer by the Ranch Fire, and then it was smashed in fall 2018 by the Camp Fire. If we look at the data since 1980, in terms of the area burned by wildfire across the western states, we can see how the dice are being loaded against us. Without a changing climate, we would have seen about 12 million acres burned by wildfire naturally, because of course wildfire is a natural part of the ecosystem across our grasslands and across the forests of the western U.S. But with climate change, we saw over 22 million acres burned, so almost double the amount because of a changing climate loading the dice against us. And lastly, of course, there's hurricanes. We're not seeing more frequent hurricanes. Now, I know the season of 2017 was particularly bad, and so was the season of 2005. But long term, over 20 to 30 years, we're not seeing more frequent hurricanes. What we are seeing, though, is hurricanes are being affected by a warming planet. First of all, their rainfall is getting more extreme. Why? Warmer air holds more water vapor. Hurricanes are very big storms. When they come along, they sweep up a ton of water vapor and they dump it on us. We also see that they're intensifying faster because they get their energy from warm ocean water, and the oceans are warming too. We don't see a change in the overall number of storms, but more of them are stronger because they're being supercharged by a warmer ocean. We also have found in the data that they're moving more slowly. So they're sitting over us for longer, which means they can dump more water on us. They're getting bigger, covering a bigger area. They're moving northward in terms of hurricanes actually getting further and further north as the ocean warms. And of course, sea level is rising too. Why do we care about a changing climate? Because it matters to us in the places where we live. It isn't just about the polar bears or people who live far away. It's about what is happening to us in our cities, in our counties, our agriculture, our economy, our energy and water resources, and more. So, what do climate solutions look like? If the impacts really do matter to us, what are some solutions that are not punitive, that are actually possibly positive for us? As John Holdren, a famous scientist who served as the science advisor during the last presidential administration, said, when it comes to climate change, there's not one choice, there's three choices. We can reduce our emissions of heat-trapping gases that are wrapping an extra blanket around the planet and causing climate to change. We can adapt or prepare for a changing climate, or we can suffer. And he said we are going to do some of each. The question is just what the mix will be, because the more we reduce our emissions, the less adaptations required and the less suffering there will be. So what do each of these choices look like? Mitigation, reducing our emissions. Well, we've got a long way to go, because when you look at Texas, we are number one in terms of the greatest amount of carbon dioxide emissions per year. California is number two. So we have a long way to go. But the good news is that there's a lot of things that we can do, and we're already doing a lot of them. Did you know that we have the biggest Army base in the US, Fort Hood, and they went with wind and solar energy 2 years ago over natural gas because they would save taxpayers about $165 million. That's how much cheaper these new sources of energy already are in Central Texas. Every year it seems like we're breaking new records. Most wind energy generated on the grid every windy spring. In 2016, we were at 12% wind energy across Texas. By the end of 2018, we were up to 19.2% wind and solar, I should add, energy on the ERCOT grid by the end of the year. And then, of course, we have entire towns and cities going green, like Georgetown, just north of Austin. We have the first carbon neutral airport in North America, DFW. I'm sure Love Field is right behind them. The city of Dallas, of course, already supplies its energy needs from clean energy sources. There's a lot of solutions that are being pioneered right here in Texas that build local jobs. We currently have over 30,000 jobs in the wind and solar energy industries in Texas alone, that invest in our local economies, that grow rural economies, providing jobs for people in places where they didn't have jobs before, that make us more energy independent, and that make us more competitive with China. Because China has more wind and solar energy than any other country in the world. What other types of solutions can we talk about? I love talking about what unexpected communities are doing, like churches or schools or organizations that plant pollinator-friendly plants and solar farms. I love talking about what businesses and corporations are doing. Walmart is the richest company in the world, and they aim to generate half of their energy from renewable sources by 2025. Apple's number 11, and they're already 100% clean energy, and they're decarbonizing their supply chain. It is possible to do good business and power it by clean energy. I like talking about what politicians are doing, especially unexpected ones. Did you know that there's a bill that was introduced to Congress in November 2018 called the Energy Innovation and Carbon Dividend Act that was introduced by Republicans and Democrats together to put a price on carbon and help spur new clean energy innovation? That's pretty amazing. I like talking about what the world is doing too. The fact that Morocco has the biggest solar farm in the world. Why Morocco and not Texas? The UK has the biggest offshore wind farm in the world. Why the UK and not Texas? China has more wind and solar energy than any other country, as I mentioned before. And again, why China and not the United States? I also really enjoy talking about what's happening in other countries around the world where they don't have ample resources of coal or oil or gas to power their economy. They don't even have transmission grids for electricity, but they have a lot of sun and a lot of wind. And 70% of the new power generation in the world last year was renewable because of exactly this issue. What does adaptation look like? We have to do some adaptation to prepare for the changes that we cannot avoid. Some of them are already here today. Some we will see in the next few decades. Looking at adaptation, we have to ask, well, what concerns do we already have today? Are we concerned about coastal infrastructure at risk of flooding during hurricanes and storm surges? Do we worry about inland infrastructure at risk from flooding during extreme rain events? Are we worried about air quality and health, about drought and water shortages? Are we concerned about social justice and economic inequity? Do we worry about aging infrastructure and costly repairs? What concerns do we already have? And then we can look at, well, how can we prepare to make our infrastructure, our cities, our economic systems, our people prepared for the risks we already face today, as well as how they will increase in the future. We've worked with cities across the country. Working with Chicago, the very first city that I ever did, we looked at all of their departments, and we found 14 out of the 18 departments identified ways that changes in temperature or rainfall could affect them, whether it's increasing the risk of potholes, warping the train rails, increasing the risk of tempers flaring. Sometimes when it gets hot, there's actually more violence and more health emergencies, especially if you live in places where people are afraid to open their windows at night. They can't afford to pay their air conditioning bills. They don't have a lot of green space. Heat is a major concern, especially in urban centers. So by identifying the risks, we can then look for smart ways that we can minimize the risks we already face today, as well as preparing for those risks in the future. Advanced agricultural techniques that look at diversifying our crops, no-till agriculture, replacing pivot irrigation with in-ground irrigation that uses much less water to provide the same amount of resources to the crops. Conserving our water and encouraging others to do the same. Restoring wetlands so that when it floods, the water actually has somewhere to go. And this is an amazing story from the Houston area. Clear Lake was already turning a municipal golf course into a wetland and a water catchment area. They had only completed the first phase when Hurricane Harvey hit, but they estimate that the first phase alone already saved 150 homes from inundation. And I love this quote from Doug Peterson. It says, "It held the water like a champ." So they're continuing with their next 4 stages in order to provide the water with a place to go when it rains, because it does rain. Adaptation in cities, green roofs to reduce the urban heat island effect and our energy load. In the Netherlands, they're looking at floating villages, so as sea level rises, you just get a few more feet of anchor chain. But then we have to say, what does suffering look like? Suffering looks like being unprepared for the risks that we already face today and how those risks are intensifying in the future. We care about climate change because it affects us where we live, but when we look around the world, we see that it is a profoundly unfair issue. It disproportionately affects those who have done the least to contribute to the problem. When we look at those who are most affected by a changing climate, we see that where they live overlaps almost exactly where people already live in poverty, where people already go hungry, where people are already dying from exposure to contaminated water. We care about a changing climate because it increases the risk of heat waves that affect us in India and Texas, hurricanes and cyclones that affect us in Africa or Florida, heavy rainfall events that increase our risk of flooding in the Midwest or in Southeast Asia, increased risk of wildfire in Norway or California. We care about a changing climate because it takes the risks that we already face today, heavy rainfall, drought, flood, and more, in Bangladesh, in Canada, in Syria, in Texas, and it exacerbates them and it makes them worse. We see that whether we live in the Arctic or along the coast, whether we live in Australia or India, we are at risk from weather and climate extremes, and as climate changes, many of these extremes are becoming stronger or more frequent, or in some cases both. The bottom line is we care about a changing climate because it alters our future conditions that affect the foundation of our society and the economy and our resources. But we also care about it because it exacerbates so many of the risks that we already face today, right here in the places where we live. So what's the bottom line? The bottom line is as we barrel down this road, all packed into this giant bus together, with our wheels already on the rumble strip, feeling the effect of this curve in the road, we need to look ahead and we need to plan for that curve in the road to make sure that we ensure a safe future for us all.